numbers nothing but, see, the imaginary number can be denoted by iota. Iota can be represented as I. So this is iota. We can call as iota. What is iota value? Square root of -1. Okay, all of you concentrate here, right? Then here the sum of the sum of four consecutive powers of I, that is I to the power of, for example, if I take n plus I to the power of n plus 1, what is I to the power of n plus 2 plus I to the power of n plus 3 is clearly equal to what?
1.
Students?
0, 0, sir. 0.
So this is clearly equal to 0. So that is nothing but the sum of four consecutive powers of the iota always equal to 0. That you have to remember. Next. So we have seen many examples like summation, iota power n, 1 to 100, 1 to 1000, like that we have seen it will become 0. Okay. Then complex number is nothing but what? Someone is asked define complex number in previous class. So complex number nothing but here we have to take any two real numbers, like for example a comma b or belongs to real number. Okay, so then here we have to take order pair a comma b. This order pair can be written as, every order pair can be written as a plus iota times of b. Okay, the set of all complex number, like this order pair is, so is a complex number. This is called the complex numbers, right? So the complex numbers are denoted by z. Okay, where here a is called, what is the name of a? A is called, exactly, a is called real part, b is
Real
called
part, I we call imaginary.
imaginary part. Okay, so that's it. So when here also you have to remember, when I take here a plus iota times of b, if b becomes 0, what is z value?
A.
Yeah,
Yes,
A.
real
yeah.
numbers.
So this is called
Purely
purely,
real.
yeah, purely real part. Okay, purely real. So the complex number becomes purely real when a is equal to 0. What is z value? Iota times of,
Imaginary.
so
Purely
what
imaginary.
is, what we can call here, purely,
Pure imaginary.
Purely imaginary.
yes, so purely real number and purely imaginary number. So in questions, they may give like this: if the given complex number is purely real, then what is the value of some k, lambda, like that they may ask. So purely real, nothing but what shall we do here? Imaginary part we can equating to 0. Yes or no? Here also the same. So what about here? I have written purely real. In that case, what is b? B becomes 0. What is b? Imaginary part. When it is purely imaginary, what about the real part? Purely imaginary, real part becomes 0. Purely real, imaginary part becomes 0. That you have to remember. And after that, already we have seen that properties of uh, some properties are there. So the simple properties, if you take any Z1 value, Z2 value, Z1 plus Z2. So we know very well how to find the sum of two complex number and the difference between two complex numbers and the product of two complex numbers. Am I right, students? The product. So everything will be easier, right? So Z1 by Z2 also. How can you find Z1 by Z2? How can you change to standard form?
Is this for OBD syllabus or NCERT syllabus, sir?
Sir,
OBT.
Z2 by Z2, sir.
Z2 conjugate by Z2 conjugate. Clear? Always see, for example, 1 plus iota will be there. Rationalizing with 2 plus iota. Am I right? 2 plus iota nothing but what? The conjugate of The conjugate
minus
of this, yeah, when I take 2 minus I is Z2, what about 2 plus I?
Z2 conjugate.
It's a conjugate, that's all. Z2 conjugate. So that multiply and dividing with Z2 conjugate, then here what will happen here? Z1 into Z2 conjugate all divided by Z2 into Z2 conjugate becomes magnitude of a modulus Z whole square. Okay, since you can see any number when Z into Z conjugate can be written as modulus Z the whole square. Is it clear? Take any number that will be equal to modulus Z the whole square. Clear? Next, coming to. So that Z1 by Z2, we know that, and also moreover you have to remember. So 1 plus iota square and 1 minus iota square. So what is the 1 plus iota whole square, students? This will becomes 2 iota. 2 iota. 1 minus iota whole square value?
Minus 2 iota.
That's all. You have to remember, because in some questions they might be asked what is the value of 1 minus iota whole to the power of 200. In case if they ask like this, what shall we do first? We have to write like this: 1 minus iota whole square whole to the power of 100. Since we know that 1 minus iota minus becomes minus 2i whole to the power of 100. Like
Sir, it
that.
will come 2 power 100 plus into I power 100, sir. So 2
I
power
power
100
100 nothing but 2 power
1,
100.
sir.
That's all. I power 100 is 1, 2 power 100 is the answer for this question. So try to remember. And also, since we know very well 1 by iota value becomes
Iota minus 1. Minus iota.
Minus iota. So remember, students, even when we cross multiply also, see here, when we cross multiply, 1 is equal to minus iota square, which implies nothing but iota square is equal to minus 1. Satisfies. So that 1 by iota value is minus iota. Remember that. Clear? The next step. After this, since we know that the conjugate of a complex number, let us see the properties of conjugate of complex number. Okay. For example, Z is a given complex number x plus iota y. What is Z conjugate among? X minus iota y. So the conjugate of Z is denoted by Z bar. Okay. For example, if I take the complex number is real number like 3, what is the conjugate? Conjugate of 3 becomes 3 alone. So conjugate of a real number cannot be changed. But in case if I take Z is equal to minus 3 iota, then what about Z conjugate?
Plus 3 iota.
That's all. Imaginary part alone will be changed. Real part cannot be changed. So after that, when we see the properties here, okay, so that we know very well. What is Z conjugate, the whole conjugate among?
Z.
Z. And also in our starting class itself, we have seen that what is Z plus Z conjugate? When you
Zero,
take
sir.
a, no, is it 0 when you are adding these two? Z is x plus iota,
Sir,
right?
2 times real
2x,
part.
2 times real part.
Exactly, 2 times of real part of Z.
Yes, sir.
Z minus Z conjugate becomes
2
what?
times of imaginary part.
Yeah, 2 times of iota times of imaginary part of Z. 2i into imaginary part of Z, because I becomes, I will be there.
Yes, sir.
Okay, these are the simple properties. And when we take a Z1 plus Z2 whole conjugate can be written as Z1 plus Z2 conjugate separately, right? And also even if we take multiplication also, Z1 into
Either
Z2 whole
whole
conjugate.
to Z1 complement into Z2 complement.
Yeah, we can write it separately. Even Z1 by Z2 whole conjugate also can be written as
Sir,
Z1
Z1 conjugate.
complement by Z2
That's all.
complement.
That's
sir, I have a doubt, sir.
yeah.
Sir, instead of a sleeping line, can we write just one bar, sir?
Sorry, instead of
Once we have written for complicate, we have written one line, no, sir.
yeah, Z1 whole conjugate. This is called bar, Z1 bar.
Yes, sir. Instead of that line, can we write any other symbol, sir?
See, in coming to sets, the complement we can write out to like EB any set, E complement like that. But in generally, in complex number, the conjugate can be represented by only this symbol alone. In sets, in matrices, we may write two, three ways. So A is any set, A complement also can be written as A dash, can be written as A bar, like that. Two, three representations will be there. But coming to here, only one representation is there. That is Z bar. Okay. So these properties and all easy properties. Then coming to, I'm going to tell you another important concept, that is square root of a complex number. Square root of a complex number. Square root of a complex number. This is important. So, for example, like, okay, right, students. If I take here any complex number, for example, we know very well how to change the standard form of 1 plus x plus iota y. How can you change it to standard form?
Into rationalize, sir.
So by multiplying with its
Yeah, rationalize with x minus iota y. Fine. This is easy. Even if it is I power something, will be the I power 10, 2 plus 3 I power 10, like that. So we may also change into standard form like this. Here it is, we can by rationalizing. But whenever it is a square root of x plus iota y, square root of x plus iota y is there, how can you change it to standard form? Standard form like a plus iota times of b.
Sir,
This square root value,
Square.
sir, into square root of x minus iota y, sir.
into square root of x,
so is it
x
square?
no,
Square, sir. That is enough, sir.
no, if squaring on both sides, nothing, but here we get a square minus b square plus 2 iota b. But I want to write in terms of x and y alone. You're saying that if you squaring on both sides, here
Yes,
we'll get
sir.
x plus iota y. Right side will go to, we are going to get a square minus b square plus 2 times of iota. AB will get. Not like that. I want to represent this square root of x plus iota y in terms of x plus iota y alone.
Sir, that only I said no, sir. Into root over x minus iota y.
Okay, if you do into root over root over x minus iota y,
Then we
then
will get root over x square plus y square, sir.
then what will happen? Numerator becomes root over x square plus y square.
Yes, sir.
Denominator again x minus iota y. Again, is it in standard form?
No, sir.
Yes. Is it in standard form? No. Again, we have to rationalize with x plus iota y. Nothing but again we are going to get same complex number alone.
Yes, sir.
Yes. And what shall we do here? In this case, simple. There is a formula. There will be a proof also. Formula you have to remember in terms of x comma y. So this is equal to, see here, two cases will be there actually. It's depending on y. For example, the two types of complex numbers. I'm going to write two cases here. Root over x plus iota y. Root over x minus iota y. Nothing but when you take only single value x plus iota y, two cases will be there. Y is greater than 0, y is lesser than 0. Nothing but if we take example, I want to simplify 2 plus 3 into iota. I want to find this value, or 2 minus 3 iota. We are going to get two different answers. No, surely we'll get two different answers because here plus 3i minus 3i. Real part, imaginary part will be same, but only plus or minus signs are changed. So in that case, this can be written as Right, I'm going to write the formula. Look at here. Two cases. One is y is greater than, so plus or minus bracket uh, root over x square plus y square. This root over again square root of x square plus y square plus x by 2 plus iota times of same square root of x square plus y square minus x all divided by 2. Whenever y is here greater than 0, whenever y is greater than 0, so this is y is greater than 0 and plus or minus same root over x square plus y square. So what shall we write here? Again square root plus x by 2 minus iota times of same value square root of x square plus y square minus x all divided by 2. Here y is lesser than 0. Y is lesser than 0 minus. So substitute here this in case if I ask here I want to find that root over 2 plus 3 iota. So what is the formula we can use here? Yes.
Sir, I greater than
The
0, sir. First formula.
y greater than 0. Y greater this condition. So simply you can substitute plus or minus bracket square root over x square plus y square, that is 2 square plus 3 square is 9 plus 2 all divided by 2 plus iota times of square root of same value here. But my here plus x, the difference is here it is plus x, here minus x. Remaining everything will be same. So this is equal to 4 plus 9 minus 2 all divided by 2. This is the answer. So all of you remember this formula. All of you remember this formula. So to simplify this, if you want to derive the formula x plus iota y, you have to equate into a plus iota times of b, squaring on both sides x plus. So this is clearly equal to a plus iota times of b the whole square. Now you have to expand. You can comparing real part, imaginary part on both sides. When we comparing here, x is equal to a square minus b square and y is equal to 2ab. So after that, here we have to find what shall we do here? We can find a and b in terms of x comma y. So a value we are going to get like this, b value we are going to get like this. Okay. So instead of deriving that, the derivation part is easy only. It's better to remember the formula. Again, if you want to write in simplest form, the same formula, we may write like this also. Plus or minus square root of, what is root over x plus x square plus y square? Shall I write modulus z? Yes or no, students?
Yes, sir.
That's all. And here comma iota, sorry, plus iota times of root over modulus z minus x by 2. That's all. Simple form. You may remember any one of the formula. And related to this, a few formulas are there. Like if you take the formula is the sum of the values x plus iota y plus root over x minus iota y. So root over x plus iota y minus root over x minus iota y. Okay, this you have to simplify. When we are adding both this, when we are adding these two, this is nothing but root over x minus iota y formula. This is x plus iota y formula, nothing but y greater than 0, y lesser than 0. When we are adding, when we are subtracting, we will get some result that you have to write it. Okay, students? This we can do, simple. Next, coming to next concept is modulus. modulus of a complex number. Modulus of a complex number. Remember this. Okay. Modulus of a complex number. So modulus of complex number can be denoted by modulus z, that is root over x square plus y square. When z is equal to x plus iota y, z is equal to x plus y, modulus z value that we know very well, root over x square plus y square, it is always belongs to real part. Is it real or is there any imaginary value? Yes. And here you have to remember that z into z conjugate is equal to modulus z the whole square. This is very important one, very important property. And coming to second one, modulus z square. For example, z cube is there. It can be written as modulus z whole cube also. We can write like this. If it is whole power n, modulus z power n can be written as modulus z whole power n. Okay, some few properties are there here: a plus b whole square, a minus b whole square, right? And modulus z1 into modulus this can be written as modulus z1 modulus z2. We can write separately. And division also, see here in advanced level we can use few properties here, like what is z1 plus z2 the whole square, like a modulus. What is modulus z1 plus z2 the whole square? This is equal to what? Like a plus b whole square, z1 the whole square plus z2 the whole square, because a square plus b square. But coming to here, 2ab, 2 into modulus z1 z2 can be written as 2 times of real part of z1 z2 conjugate. We can write like this: real part of z1 z2 conjugate. In the same way, if we take minus here we are going to get minus, plus it will be plus. If it is minus, here also minus. In the same way, when we are adding these two, modulus of z1 plus z2 the whole square plus modulus z1 minus z2 the whole square, this is equal to what, students? When adding these two get cancelled, 2 times of z1 square plus z2 square. These are the simple properties. Okay, right. Next important concept. Two times of real, but even if you get any doubts, you can take any two complex number. Example 1 plus I, 2 minus I. You can take any two complex numbers. You can find their left side LHS value. You can evaluate RHS value. Then you can compare that. Surely,
There is that two
both will
times
be
real part of z1 z2 conjugate, sir.
conjugate. Yes, z1 z2 conjugate. Even you may write z2 z1 conjugate also. That is also correct. z1 z2 conjugate I have written. Instead of that, z1 conjugate into z2, you may write like that also. Clear? So here we can apply some inequalities that already we will see in inequality chapter. Inequalities. Okay, so here coming to the inequalities, what are the inequalities we having? So if you take any two complex number, then the first one is when I take z1 plus or minus z2 always lesser than or equal to z1 plus z2. This is always true. This is one of the important inequalities.
So this
It may
triangle
be,
inequality only, no, sir.
yeah, triangular inequality. Okay,
Why
in
is it known as
inequalities,
triangle inequality, sir?
hmm?
Why is it named triangle inequality, sir?
So we are representing with else here in geometry also. Geometry, we are going to find orthocenter, circumcenter, centroid, okay, in center, okay, eccentric. So all that concept with help of complex number also we will find here. This is belongs to actually triangular inequality. This we will discuss in vectors also. This we will discuss in complex numbers also. This we will discuss in geometry. The concept will be same. If you take any two sides like as a complex number, you can take triangle, take Z1, this is Z2, then Z1 plus or minus Z2 is remaining side will
Resultant.
be resultant will be becomes modulus Z1 plus, it will be lesser than or it may be equal. It is either plus or minus. So this is true for any two complex numbers. You can take any two complex number, it will be satisfy always. Clear, students? This property we may apply for some finite number of complex number like Z1 plus Z2 modulus Z1 plus Z2 plus so on plus Zn also can be written as modulus Z1 plus modulus Z2 plus so on modulus Zn. It is lesser than or equal to compulsory. Okay. In case the second property, I'm going to write here one of the property here. In case if I take here modulus of Z1 minus modulus of Z2, this is lesser than or equal to modulus of Z1 minus Z2. Because modulus means it is a positive. Modulus, it is a real number. But minus it minus, sometimes it will becomes plus. Okay, I'll give for every property example while solving many problems are there uh, which is related to these properties. Okay, and mainly here you have to remember first inequality. This inequality you may or may not be remember, but first one is very important. Coming to third one, some cases here z plus 1 by z. When I take z is equal to x plus iota y, x plus iota y, then z into z plus 1 by z. Otherwise, if I take this value is a, which implies that what about here modulus z? So in this case, the modulus z becomes two cases will be there. Modulus z, in that the first one is minus a plus root over a square plus 4 by 2a. Nothing but minus b plus or minus b square minus 4ac by 2a. When we take LCM here, LCM, z square plus 1 by z is equal to a. When it z cross multiply and simplify, we are going to get z square minus plus or minus we can take. When we remove this modulus, here we are going to get plus or minus a. Plus or minus a. So plus or minus az plus 1 is equal to 0. Like we are going to get a complex quadratic equation in terms of z here. So the roots are minus b plus or minus b square minus 4ac by 2a. Like that. Okay, students? Like that. So when z plus 1 by z, these are the in even previous year also, once they asked the question which related to this property. Okay, so I know that it is very difficult to remember all the properties here. Right, next concept is argument. Okay, argument or another name in NCERT we studied about just argument. The theta is called argument or else the another name is amplitude. amplitude of a complex number can be denoted by theta. Argument. So this is simply if Z is any complex number, the argument or amplitude of the given complex number is denoted by ARG of Z. ARG, simply argument of the complex number, simply we can written as ARG of Z. See, is that clear, students? So principal argument means the theta value lies between where to where? This is equal to theta. When theta value lies between minus 180 to
Plus 180.
lesser than or equal to plus 180, then here theta is called principal argument. Principal argument. So principal argument nothing but we can take any point in the complex plane or argand plane. Argand plane. Okay, that can be, for example, if I take PB any point here, like P of x comma is any point, it can make an angle theta. Okay, in positive direction. This theta is called principal argument or okay, this might be clockwise direction or else anti-clockwise direction. If you take anti-clockwise direction, theta is positive. If we take clockwise direction, theta will be a negative value. Clear, students? Right. See here. Principal argument means theta value lies between minus 180 to plus 180. Here there is another argument, general argument. General argument. What about theta? When theta value is like a theta is the generally we can take a principal argument, but theta can be represented as 2k pi plus theta. Theta nothing but you can take this is theta 1, or else this theta 1 you can take as alpha. Okay, what is alpha? Alpha is a principal argument. Principal argument. Then the general argument is given by, to the principal argument we can add 2k pi. That's all. Okay. Then the general argument is, what are the principal argument here? Theta. Here minus theta. Here pi minus theta. Here minus of pi minus theta. That's it. This principal argument is said to be general argument. Just we can add 2k pi plus 2k pi. Here 2k pi. Here 2k pi. Here 2k pi plus. Okay, here k is belongs to Z, capital Z or else integer. K is belongs to capital I or capital Z. Okay, students, for principal argument, we can adding the 2k pi, then the argument becomes, principal argument becomes general argument. Any doubts, friends, still here?
Sir, K belongs to capital I. What does that I mean, sir?
Capital I nothing but integer, set of all integers.
Yes, sir. Yes.
Okay, integer can be denoted by capital Z and capital I. This is the general argument. Okay, for principal argument, just we can add it 2k pi, principal argument becomes general argument. Clear, students? Right. So what is the argument of 0? Anyone? What is theta value when I take Z is equal to 0? What is theta value? Yes, tan inverse of y by x, no? Theta nothing but. If you not remember, simply remember tan theta
Y by
formula. Tan
theta.
theta formula is y by x. Okay, from this one, we are going to get theta value. See here. If I take PB any
Y by
point here.
theta.
Yeah, y by, what is the value?
Y by 2.
Pi by 2. Are you sure?
No, sir, pi by 2
So,
will not.
Sir, it is
tan
not
theta
different,
is,
sir.
is it not
I by
defined?
2.
Z is equal to 0. What I'm asking, what is the principal argument of z is equal to 0. Then tan theta is equal to what? Y by x. What is y?
0.
0. By?
0.
Then
Tan
what
theta
about tan theta? Is tan theta is defined?
Infinity.
not defined.
It is not defined. So,
Then 90 only.
no, not defined means we cannot find any argument. We cannot find the theta.
Sir, if tan
Zero.
theta equal to 1 by 0 only, then
See,
it is 9.
Here 0 nothing but 0 comma 0. Where is 0 comma 0? At this point, it is just a point.
Okay, sir.
Is there any line? Is there any length to make an angle? Nothing will be there.
Understood, sir. Understood.
It does not exist.
Yes, sir.
Is that clear to remaining students? So these are the small points but important. The argument of 0, whether defined or not defined. It is clearly not defined. Because 0 by 0 is undefined. 0 by 0 is undefined, right? Let's discuss some important result which is belongs to the argument. Argument of z is there, plus argument of z conjugate. Like if I take a z is equal to x plus iota y, what is z conjugate, students?
X minus iota.
X minus iota y. Then what is the argument of z y by x? Argument of z conjugate minus y by plus x.
Minus will be x.
Yes, tan inverse of minus y by x. This is equal to, whenever we find that, we are going to get two results, 0 and 2 pi. Okay, both will be coincide. One angle is 0, but another angle it will make one complete rotation when it is possible. When your theta students other than 180.
Theta not equal to pi.
Yeah, for any value of theta other than 180, it will be 0. Like it maybe take 30, 40, 60, 50. Okay, other than 180. Whenever theta is exactly 180, argument of z plus argument of z conjugate becomes 2 pi. Okay, students?
One minute, can you scroll up, sir?
When the video is turned on. Okay.
Sir, those who have copied can leave. Sir.
Yes. Take the break.